Oh. Hey, guess what? The recording's in progress. We better answer our questions here on the screen. You?
Yeah.
Send an alarm for 9 o'clock.
Oh, thank you. Please do. Set a reminder for 9 o'clock. Our screens roll back up at 9 o'clock.
Whether you
So,
want to or not.
it's an interesting phenomenon. Welcome to the May Omaha Astronomical Society meeting. Yay! Folks at home on Zoom, if you have headphones, you can use them if you'd like. You please remember to mute your microphone if you're not speaking, and you can use your space bar. If you do not want to be seen, you can mute your video. And to file a motion, members can unmute and say aye. Do we have any guests this evening? Hi.
Came to see what it's all about.
Oh, really?
Yeah.
Tell us about yourself.
I've been here once before and then
Oh, of course.
maybe once a year. Drop.
Well, last
Or
time I
every
was
2
here
years.
was pre-COVID.
Yeah.
Well, welcome back.
Welcome back. I mean, it's family. I mean,
Yeah, so you can take.
I think the last time I was here when the eclipse was coming through. You had some speakers.
all 2017.
Yeah, so that-
Yeah.
Wow.
At least tell us your first name.
Yeah,
Mike.
Tom.
Another Mike. Another Mike.
All mics, please raise their hands.
gotta be-
All right.
John's?
Please, Johns.
Only two then.
Oh, there's only 2 of us. Okay.
I'm a guest.
Is there anybody in Zoom who's a guest?
I'm not a member.
You have a family member.
Oh.
Yeah,
Family included.
It wasn't by choice, darn it.
You know
They
what?
were just drug here. Yeah.
That's a very good point, because if you decide to become a member, you'll also be a member of the Astronomical League. And you'll receive the Reflector Quarterly Magazine.
Got yours?
Right there. Thank you. It's like it's planned. Access to Astro Park, our observing site in Weedman, Nebraska. We have a great telescope loan program. And you can try the telescope, observe, and experience different types of scopes. Our monthly newsletter, the Stella, which has got a lot of information in it. And we have a Discord server for members and such. Members can make and vote on motions during the business meeting.
John,
Yes.
do we have a guest over there or is this young lady?
Hello, put her on the spot like.
Hello. Hi.
I'm Audrey.
Hi, Audrey.
That's what I thought, Audrey. I'll catch you a break.
How did you hear about us?
I did the teacher.
Oh, cool.
Who found out from me.
Okay, very good.
Welcome.
Has anybody been out to Astro Park the last few weeks? Is the road still closed past the gun club?
I believe so.
I haven't been down there, but I have friends that it should be for another 2 weeks, maybe longer.
We had a couple people there about 2 weeks ago. And the tree was cleared that had fallen down upon the road to Astro Park. And the bridge was closed at that time. So that was around the 20th of April. Astronomy in the Park's coming up on Tuesday, and the NSP Mahoney Star Party is coming up the 26th. More in outreach. The Omaha Astronomical Society, while being a member of the Astronomical League, we also have a group chapter that we're in, which is the Mid-States region of the Astronomical League, or we call it MISRAL. The MISRAL convention is coming up next month, almost exactly a month. It's on the 9th through the 11th in Jenks, Oklahoma, which is outskirts of Tulsa, not unlike Millard in Omaha. We're also a member of the Night Sky Network. We do get some communications through there. Usually it's sort of like to help find OAS. And we do have a number of fan shop items. No hoodie tonight. Oh, can I get a t-shirt? Did we have anybody go to Astro Park in the past month? One. Anybody online go to Astro Park? I'm sure there was more than one, but. I'll put one. Awards chair.
Hello, we have no awards this month. There are so many awards out there that one can go for, everything from, beginner to advanced, all kinds of things. Check out the, website here if you want to see that. You can get an outreach award by completing just 10 hours, 5 events of at least 2 hours each. You can get a cool, certificate and pen, so consider participating in outreach and keeping track of your hours. Let me know if you wanted any information.
John, Steve and his wife were out at Astro Park.
Thank you. I just saw it. I appreciate it. Thank you.
3.
3. If we count Mike Gallagher, who was also there, I guess that's 4. Observing chair. That's Sonali. Tomlin's distracting.
Steve also notes on our chat that the logbook showed a total of 8 since the work party.
Oh, wow. Well.
Solid.
It's on.
All right, so May, today is full moon, in case anyone saw the moon today with the clouds.
It was pretty last night.
It was actually pretty nice last night, late last night, yeah. Well, for the planets, Venus is spectacular in the evening, so definitely go out and have a look at that. Throughout the month, it moves from Taurus to Gemini. In the morning, you have Saturn, Neptune, Mars is in the evening. Mercury inferior conjunction on May 1st, and you should be able to see it then later in the month, towards the end of the month. Jupiter is a morning planet, and on May 17th, the moon will occult Jupiter, and it's going to happen at 6:36 a.m. So I'm kind of excited to see if we can see that or not,
See,
or how well.
Sun's coming up.
Yep, it is. So it may or
Yeah, the
may
sun
not.
will already be up, but I was reading, but yeah.
Yeah, I suppose if you can see the moon, you'd be able to see Jupiter close enough.
Yeah, you
might be
able to.
So it just might be.
At least
Yeah.
with binocular, but with telescope, it'd be easy.
So that's something that's interesting this month. The moon and Saturn are close on the 13th, and moon, Mars, and the Beehive cluster on the 24th. So a couple of nice events. And for those who are not familiar with what an inferior or superior conjunction are, when a planet is between the Earth and the Sun, it's called inferior conjunction, and that represents Mercury. And superior conjunction for Uranus is on May 9th. And when it's on the opposite side of the sun from the Earth in 180 degrees. So that is a little diagram to represent that, not to scale, obviously. As I mentioned, full moon tonight, or this afternoon at about 12:30, and new moon on May 19th. Meteor showers, the Eta accurate from April 19th to May 28th, with the peak being tomorrow. And since it's just past full moon, so maybe not as great, they are low on the horizon. And for where they are on the horizon for Omaha, the peak is about 19 an hour. But if you look at various sources, it says the peak can be anywhere up to 40 an hour. And the source is Comet 1P Halley. And that's all I have for this month. Thank you.
Where I once belonged. You think I didn't know how to use technology? Outreach. I don't think that's a complete list, is it?
No.
Hey, John Larson, you got really quiet.
I guess it is. You understand?
Oh, sorry. I said outreach.
Now we can hear you. Thanks.
Okay, not a whole lot going on. We got, next to this coming Tuesday, our standard astronomy in the park at Lake Zurinsky, starting at sundown. 156th and F Street, entrance to the soccer fields there. We'll, hopefully have a nice weather. It looks like maybe some clouds on the extended forecast so far, but we'll see. And then Friday, May 26th, we start the first of the Nebraska Star Party sponsored events at Mahoney. We do those at the driving range. You have to have a park pass to get into Mahoney. But it's also Memorial Day weekend, so this could be I imagine Mahoney will be fully booked, so it could be quite a few people that are looking for something to do in the evening, so. If anybody's willing to come out, if you already have a park pass, great. If not, I think it's like $8, $6 or something. I don't know what it is.
In state, I think it's a day.
Buy the year pass and then you can keep coming all the next months. It'll be fun. Let's see, and then, so that's on Friday, the 26th, with a potential cloud out, rain out, whatever date, to fall back on the following Saturday, the 27th, which is also a event, it's the first of the year for the Lauritsen Gardens, that we do on occasionally at those. So hopefully we'll have good weather on the 26th and then we can have do both of them.
What is the Lawrence Gardens event?
So those are, they're kind of private events that, Lawrenson has us come in, to do a star party out by the Rose Garden. And they sell tickets to their members. Or you have to be a member, anybody may a ticket, but they sell tickets and then they bus or tram, whatever you want to call it, a group of people out, there's usually about 20 of them, to the little circle around by the Rose Garden and, right. It's just, it's a nice little.
So you have to be a member, first of all, right?
Just the general public, I think you get a really good price break. You know, they charge for their
well,
public. to
We're
come to
members,
this.
I'm just trying to.
Yeah, members of the OAS that volunteer to help. No, we just gather about half hour, 45 minutes before, and they take us back there.
It's fun, you get to drive your car back into the gardens.
Yes,
Then there's a charge at Lawrence for the event itself.
for the public.
For the people that are coming, yeah.
Oh, I see.
I think it's even if you are a member, there's still a
Surcharge. Charge. I'm thinking $10.
I don't know what it is, but I'm sure they sell tickets. You have to purchase a ticket.
It might be on their website.
They'll be on their website, and if it looks like a good weekend, they're usually sold out. Yeah, because I think they limit it to 25 maybe.
Yeah, it's not, there's never been a whole lot. But it's, they're all right, you know, you're dealing with downtown light and stuff, you just gotta find whatever you can find there. This one will be better because it should be,
We'll have a quarter moon to look
yeah,
at.
it'll be a decent.
Do you
moon.
bring your scope or do they have them there? or-
No, we have to bring ours.
Yeah, we'll bring all of our scopes out to set up for them to look, yeah, but they hire us, but they bring us in, we set up our scopes. And then they bring their guests in and they look through our scopes. If you're a member or a member of the gardens and you sign up for it and you're not an OAS member, and you're more than welcome to still bring your own telescope. I don't see any reason not to, but.
Thank you.
I think that's it for.
The only other thing was the Nebraska Star Party. John, were you going to say anything about that? Since Eric's not here, you want?
Sure.
Well, you want me?
Hang on, let me just.
Just that it's in the newsletter and we got brochures.
Yes, the Nebraska Star Party is coming up in July. We have some flyers up front. It is the 16th to the 22nd. This is the 30th annual. So it's going to be a great time. I have been to every one since 2010 personally, including the not star party of 2020.
2020.
There were still 70 people out there. We were very easy to social distance on the observing field.
Not Star Party.
It's still NSP, not Star Party.
Well, I got to show them again.
The registration is available. Be sure to register before June 15th to save on the registration costs. There are commemorative t-shirts you can also sign up for. And if you don't know, Merritt Reservoir is now an international dark sky park that has been a labor of love for people here, as well as our friends at Nebraska Tourism.
It's the first in Nebraska and the 200th in the world.
Look at that, the first in Nebraska and the 200th in the world. So I believe there was the program was to change out 87 light fixtures.
At least that, yeah.
So at least minimally to be part of getting that specification. And there's a number of programs that kind of feed into that, right? NSP
Yes.
is one, and then there's some other
They held one,
ecology and
yeah, they held one last Saturday
yeah,
and it was, I think they said they had 15 people show up.
that's good.
And they'll have another one in June and one for along with the Star Party and then one in September.
Nice. Did I do okay? Hooray. Thank you. Oh, telescope loan program. Stafford, I did not update this list. I apologize for that. You have a list on your,
Mine for the first time is somewhat up to date.
all right.
I'm gonna do the thing here I was told never to do when we gave briefings, which is look at the slide. The refractors, they're all available for us if anyone has an interest in those. Let's see, yeah, they just came back, so the 11 by 80 binoculars are available to us. The 8-inch just got checked out this past month. The Meade 2080. I have it listed on my list as out for repair because it needs a fair amount of TLC. If you want to struggle with a bad secondary mirror, it is available. The Celestron 4 SE is also checked out till June. I have a train load of Dobsonian reflectors if anybody has a desire to check them out. And let me see.
I might not have some of the newer ones.
Yeah, the 10-inch number 1 is available. 10-inch number 2 is retrievable. The 13-inch is suffering also. I have that one listed as out for repair. Let's see what else.
Might be a bench warmer.
Yeah.
What's that one need?
Oh, yes, I forgot to mention the Coronado
It's very bulky.
is has been renewed. The person who wanted that contacted me last week. And I think. Yeah, I think I covered them all, so that's all I have here.
Thank you, staffers.
The FRP, Stafford? So, the FRP,
FRP. I did find some.
okay, you need to have a bunch of extra due to circumstances.
Due to circumstances.
Thanks for
Program chair.
Hello. One sec. Good evening, everyone. I'm not sure if Allison is physically at the meeting tonight, but
She's right over there.
we heard her tell us a little bit about her meteor research experience a few meetings back, but I'm very honored to have her back talking to us again tonight about her position at the Lowell Observatory and their extremely incredible, long-lasting program, kind of very unique, one of its kind in the whole world, and their research into comets. And I had the pleasure of chatting with her a few weeks back about all of this and her experience there and how in depth everything is there. So very excited to have Allison there back with us tonight, and we will have a very exciting program.
Cool, thank you, Jordan. Cool time. Tom has some pictures for tool time. So where were you, Tom?
My house,
This was your house.
that's Whitmore and 52nd Street.
Wow. Your camera picked it up, huh?
Oh, yeah. My neighbor's house. So I told his daughter I'd get her some pictures and I gave him.
It's the Aurora.
Could we
You need to
shut
shut
the lights
so they can see it better.
Oh. Hang on a minute, I gotta do the walk.
Walk a shame.
Stare amongst yourselves.
Is that the only place you can turn them off?
There's no switches up front.
Yeah.
That was a mistake. That was intentionally a mistake, yeah.
But this one? No, this one?
There you go.
There you go.
All right.
Oh, that's a power line. That's not a,
It's a dark jet.
that's a dark contrail in that picture.
What pissed me off, I took a picture of the milk or the Big Dipper, and as I took it, got done, and I looked and all of a sudden. Question there for you.
Has a question.
So Kim has a question. So I think this was the 23rd.
Yeah.
According to the picture, what was the rest of, let me pull this up, rest of the question.
What did you see with your eyes versus the camera?
Nothing.
Nothing. Couldn't see.
It
with your
it looks
eyes?
like clouds, of haze that kind of lights up a little white.
You got a little bit over here.
You can see, that's the red in there.
Uh-huh.
One of the pictures, I don't know if these, I got the good ones here, but one of them showed a lot more,
There, you see the spike?
and you can see it, and that's actually first light for somebody's telescope that's sitting next to me.
Right there, okay.
How long are your exposures?
That's about 5 seconds.
3 seconds. F2.8.
14 millimeter.
14 millimeter lens, ISO 3200, Pentax T3. Pretty cool, Tom. 4 seconds. The trees look like they're glowing.
Don't they?
Yeah.
And if you take pictures that are in the same spot and you move through them faster, they're not on here. But on my camera, when you go next, you can see the sheets move.
Oh, like, oh,
Yeah,
we should make an animated GIF.
Make a
for you.
little,
yeah, that's what I'm thinking of.
Nice. Thanks, Tom.
Did you get to Kim's question?
Not yet.
Okay. She asked the date of the aurora and what did you see opposed to
Yep.
like the camera with your eye?
Yep, we got it.
Okay.
That's because Stitch walked out the picture.
No, I can see Cassiopeia right here.
Yep.
The big W. Thank you, Tom. Let's see, on the 20th of May is the OAS Club Star Party at Astro Park. Yes,
One more thing, at my house, I've got Mormon Bridge and all that, but I can see all the stars in Cygnus at night with the street light and all the stars in the Big Dipper easy. So it's not so bad that far up, but
yeah,
the other one with was over by Neil's Woods, the first light telescope. But it was cloudy that night. And
I hope we have good weather for the 20th for our star party. That'll be fun.
luck. Yeah, it'd be nice.
We've had a few. The question is, are we cooking?
I was just gonna ask about it.
Club Star Party, right?
yeah.
Yeah, I guess I am.
Yeah.
So bring a side dish. And beverages. I wonder if it'll be a warm night or a cool night. You may need to recharge your hand warmers, John.
Yeah.
Those little battery packs. Fire pit, I can bring my propane one. Okay. That'll be I should do that.
Worked good last time until the flames started shooting out the sides.
Yeah. We just had to tighten that up a little bit. I think our next component is the presentation. Do we want to take a break for a moment or?
Yeah.
Okay, 10 minutes, 8:05. Okay, let's take a break and then we'll come back for presentation.
Probably go in the trash.
Nice banding and stuff.
Yeah.
Yeah, so.
That was out of NSA.
He had one on.
Kim mentioned on the chat.
They used.
That was even longer than that.
Yeah. Taking everything, let it sit.
There we go. Now we have it on film, right? Okay,
Use the mouse.
you can use the mouse as a pointer. Yes. Jordan, do you want to do a intro or do you think you did good with the previous one?
I think I did good with the previous one, but thank you anyway for asking.
Boy, Jordan.
We got
your voice
Gordon,
got deep.
We got.
Oh, Gordon. I said Jordan.
We're good, we're good. Allison can take it away.
Oh, I love it. That's great.
Okay, can you guys hear me okay?
You can see all right?
Yeah. And I'm sorry to cut in on Jordan.
If you want, John, you could move in a little closer to the presenter for the host picture.
All right, so I think a lot of you know me already. Are we good? Okay. Oh, there's a camera for me.
Backwards and all this camera work.
Mirror.
So
Yeah, it is.
right now you're in. You got like this, then you can go like-
Okay.
Hey, there you go, much better.
Okay, so I'm Allison Bear. I do live here in Omaha. I've been here for almost 6 years now. But I work remotely for the Lowell Observatory. I started working there in 2005. And I'm currently a research associate there with Dr. David Schleicher. I have a master's degree from Northern Arizona University, and I work directly with an astronomer there. When I first started at Lowell Observatory, I did outreach. I started there soon after I graduated from my master's program. For outreach, I gave tours, gave presentations, and the best part of doing outreach at Lowell Observatory is operating the 24-inch Alvin Park refractor. So those are just some pictures of that because why not? So that's how I started there, and then I got connected with Dr. Schleicher. He needed someone to help him with his comet photometry program. We were a pretty good match, and so I started working for him to pick up hours when the outreach season was slow. And then in 2008, he hired me full-time, and so I've been working for him full-time since 2008. So I'm going to talk to you about our comet program, but before I actually talk about our research, I just want to do an overview of what are comets so we can all kind of understand things as we go along. So comets are icy bodies. They're comprised of dust, rock, ice, frozen volatile compounds. This is like frozen water, frozen ammonia, various carbon compounds, carbon monoxide, carbon dioxide. These are the leftover materials from when our solar system formed. And they are kind of a rocky, icy nucleus that is usually a few hundred meters to a few tens of kilometers across. And these are just some images here of some nuclei that have been imaged by spacecraft, so we can see them up close. So as comets move closer to the sun, solar radiation causes the volatiles on them to sublimate. Sublimation is that the ices go directly from a solid to a gas. There's no liquid phase in between.
This entrails dust in it, and so we get a big tail, or sorry, a big coma around the nucleus of the comet, and this goes out into a trail behind it. The tail behind it, my apologies. So this is a little kind of schematic of a comet. Nucleus sizes, again, they range from less than 1 kilometer to tens of kilometers wide. The coma around the nucleus can be larger, can be as large as a planet, can be the size of Earth. And as they move away from the coma, the gases and dust form the tail that stretches tens of thousands of kilometers behind the comet. I say behind, and I should be saying away from the sun. So the tail is always in the opposite direction of the sun. Comets generally have a greenish blue color. This is due to photons from the sun ionizing certain gases on the comet. For the blue and green, this is usually from cyanogen Cn and a diatomic carbon C2. These fluoresce blue and green. The comet on the left is a very gassy comet, so you can see its bright coma and its beautiful ion and gas tail. The comet on the right is Comet Hale-Bopp. It was a very dusty comet, and so we see the ion tail, that blue tail, kind of going up into the right, and then we see a yellowish dust tail. The dust tails look yellow because they're reflecting sunlight, and since our sun is a yellow star, the dust tails usually have a yellowish hue to them. So soon after the planets formed in our solar system, this leftover debris was thrown out into various areas of our solar system, and they kind of coalesced into 2 different reservoirs or 2 different areas. A lot of them ended up in the Oort cloud. This is a spherical shell that's around our solar system. It's very far away. We think it starts around 2000 AU away. At 1 AU is 1 astronomical unit, which is the distance from the Earth to the sun. So we think it starts around 2000 to 5000 AU out, and it can stretch maybe up to 100,000 AU. So it's very far away. It's very large. The other reservoir for comets is the Kuiper belt. This is out where Pluto hangs out. This is kind of like more of a donut shape that goes in the plane of our solar system. And this is where our periodic Jupiter family comets are coming from. I don't know if I mentioned the Oort cloud is where our new comets, our long period comets, and also our Halley type periodic comets are coming from. So what takes a comet from hanging out in this reservoir? What makes it come closer to Earth? And this is due to gravitational interactions. Usually for our Kuiper belt comets, they're interacting with Neptune. Neptune will give them a nudge and they'll push them in between Neptune and Jupiter. And this is the Centaur region, so they usually hang out there for quite a while. And then eventually they might get another nudge from one of the big planets, and then that will either eject them from our solar system entirely, or it could send them on a course towards our inner solar system. And then they will get caught in the orbit of Jupiter, and they become our Jupiter family comets. And these are periodic comets. They have an orbital period of less than about 30 years. And again, they're going more or less in the plane of our solar system. This is an orbital diagram of 67P Churyumov-Gerasimenko. This is the comet that was visited by ESA's Rosetta mission about a decade ago. And this is has a pretty typical Jupiter family comet orbit. And again, I just want to point out, I'm going to use the mouse here. This orange orbit here is Jupiter, and the white is the comet. And so you'll see it's more or less in the plane of our solar system, and it's kind of hanging out by Jupiter. Jupiter keeps it in place. For our Oort cloud comets, they also come in due to gravitational interactions, but they're of a different kind. These are from random passing stars, encounters with giant molecular clouds in the galaxy, or even interactions from the galactic tide. And again, these are coming in, they're not in the same plane of our solar system. And we have periodic comets that get caught. These are our Halley type comets, or we have long period and dynamically new comets. These are on much longer orbital periods. And this is an orbital diagram of Halley. So again, I want to point out Jupiter is this orange here, and then we can see Halley coming all the way out here. So it goes out to about Neptune. And again, our solar system is more or less in a plane, and Halley's coming in from the south. So it's got a very different inclination. This is Hale-Bopp. A lot of you may have seen Hale-Bopp when it was around in 1996 and 97. This is its orbit. This is a long period comet. It has an orbital period of about 2,500 years. So you can see again, it's just coming in from a crazy angle and going back out again. Another long period comet. This is 2017 K2 Pan-STARRS. This was one of our bright comets last summer. I know Sonali saw it last summer. I'm sure some of you, others were able to see that one as well. That one has an orbital period of about 19,000 years. And then, oh, it's not loading. Oh no. Huh. Well, I'll just show you with my hands, maybe I can. So I was gonna show you Borisov, 2I Borisov. We have another class of comets there that are interstellar objects. They start with an I. And we only have 2 of them so far. One is 1I Umaumala, and that one was asteroidal. But the second one that came around in 2018 was 2I Borisov, and it's cometary. And I'm going to show you on one of these charts, if you can see my mouse. Instead of going in and out, it kind of came down like this, and then it went back out in this direction. And so it's got this very, it's not coming back. It's not in a parabolic orbit. And that's how we knew it was interstellar, because it's not gravitationally bound to our sun. It just happened to pass by us. And I'm going to talk about Borisov again in a minute. Okay, so yeah.
What is the difference between asteroidal and?
It's a really good question. So to be cometary, we need it to be outgassing. And so Umaumala might have been outgassing a little bit, because it was not the velocity that it was moving indicated that maybe there was something propelling it. But we saw no actual outgassing. We saw no sublimation of gases. There was no tail. The various CCD spectrographs, anything that people were trying to take, but we had no indication that it was outgassing.
So more rock than ice.
Exactly, more rock than ice. Borisov behaved just like a comet. All right, so why do we study comets? Because they're composed of the primordial material from the era that our solar system was formed, and they're kept pristine out in the Kuiper belt and the Oort cloud. So they're pretty much in cold storage, just hanging out there until something happens to nudge them in, and then we can observe them. And as they come in, we can get various clues from them about the composition and temperature of the outer protosolar nebula, so out beyond the snow line where ices could form. And we think that they were a source of water for Earth. This is why my husband Sasha made for us tonight. You probably can't see mine. He made us some comet juice for tonight. So if anyone's thirsty, we have some comet juice. They were the source of water here on Earth, also a source of mass extinctions, and they very likely delivered the building blocks of life to Earth. Wait, my pictures aren't showing up. Oh no. So it was a pretty comet. I don't remember which one for this one. That's the comet picture. I'm not sure why they're not showing up. It's very interesting.
I had some issues earlier.
Did you? Okay, just a second.
See, it's not loading anything, which I can kind of see.
Yeah.
Sorry, I hope.
That's okay. This was a comet. So this picture, a lovely comet. So our comet narrowband photometry program was started in 1976 at Lowell, and this was in anticipation of the return of Comet Halley that came through in 1986. And Halley was going to be the first comet that was ever going to be discovered, or not discovered, but visited by a spacecraft. And so as it was coming in, NASA actually gave a fair amount of money out for people to study comets, to try and put Halley into context, because it's like, oh great, Halley's coming through, we're really excited about it, but how can we say much about it if we don't know how it compares to the other comets that are around? And so how do we put spacecraft targets into context? We do that through ground-based observations. One, it's a lot more affordable, right? Because we're not having to go up into space to do it. And also we have so many comets available for study. And so they started this photometry program in 1976. This was a gentleman named Micah Hearn. He was at the University of Maryland, and Bob Millis, who was at Lowell Observatory. They started this program with the goal of obtaining homogeneous photometric observations of comets in order to elucidate their similarities and their differences. And so with this main overarching questions, I guess, of do comets show evidence of surface evolution? So what can we tell about them, their physical processing as they're coming closer to the sun? And what are their chemical compositions? And can we tell any differences of their surface evolution or their chemical composition based on where they originated? So is there a difference between these Kuiper belt comets and these Oort cloud comets? The main telescope used for this project is a 1.1 meter telescope at Anderson Mesa, just outside of Flagstaff. This is our workhorse telescope. It's been on the Mesa since the 60s. It's readily available, so we get a lot of nights a year on this telescope. And we use what we do is narrowband photoelectric photometry. We use a photo multiplier tube and a pulse counting system. So it pretty much acts as one giant pixel. If you think of a CCD camera, when the light comes in, it gets divided to all the various pixels. Whereas a photometer is just one giant aperture. And so you're not getting a picture out of it, but you're getting a signal that comes through it of the light. And we use narrowband filters along with that photometer. And we've got 8 of them in a UV through green. And this was supposed to be a picture of the spectrum, just showing the area that we observe. And so we do UV through violet, through blue, through some of the green. And that's the area of the spectrum that we observe. So how do we know? We know we want to study certain wavelengths of comets to get chemicals. So how do we know which wavelengths we need to isolate to get the chemical signatures that we want? And we do this by looking at spectra. Spectra are taken with a spectrograph. And it's pretty much a slit that's centered on the comet, and it samples a cross section of the comet. The light comes in through the spectrograph. It goes through a diffraction gradient grating that's pretty much like a prism. It divides the light up into its various components, and it measures the strength of the different wavelengths in a comet. And since different chemicals fluoresce at different wavelengths, we can get a spectrum of chemical signatures. And so this is a typical comet spectrum. And what I want to show here, the location of our narrowband filters. So we measure OH. This is down at 3090 angstroms. Because Flagstaff is at high elevation, 7,000 feet, we can measure into the UV. Here in Omaha, we have too much atmosphere above us. And so OH is, we can't measure, we can't detect it here, but at 7,000 feet in Flagstaff, we get OH and NH. And then we also get CN, C3, and C2, and then various bands of continuum. And so OH is a direct byproduct of water. So by measuring OH, we know water production. NH is from ammonia, so we can measure ammonia production. CN is from HCN, and then C2 and C3 are from complex hydrocarbons. We're probably measuring granddaughter species by the point that we're getting these carbon molecules. And then we also measure dust, and this is reflected light, and we measure these in our areas of continuum. So we use a photo multiplier tube. So we have our telescope, we have our filters, and we have a photo multiplier tube. The filter isolates a very specific wavelength that it lets into the photometer, and then the photoelectron signal is multiplied as it travels down the tube, and it comes out at the end as we get counts per second for various gas species. And there's this clear advantage of using this over spectra. It's that we can get photon counts for much fainter objects. Again, it acts as one giant pixel, so we can go fainter. So we get the less active or further away comets. This increases our sample size. We regularly get to 14th magnitude comets with this instrument, and sometimes we can get up to 16th magnitude, depending on what we're looking for. So our database as it stands right now, this has been my main job for a while, but I've been working on various other projects as well. We have 220 comets that have been observed over the span of 45 years. Nearly 900 nights of observations, almost 5,000 individual data sets. And we define a data set as a set of measurements through each of 2 or more of those narrowband filters. So we need at least 2 of those filters for it to constitute a data set. And then we take those, our photon counts, and we calculate production rates, and those are reported as molecules per second. And so something I just want to drive home, this is a very large and very unique collection of data. It's been the same observers overlapping, but over the years we've passed it on. Same locations, this mainly at Lowell, but we do have a few other observatories that we have used. The same 3 photo tubes, the same collection of telescopes, and the same filter sets, all calibrated to work together. And so we have a uniform reduction of all of this data. And we also, for a lot of the short period comets, we've observed over multiple apparitions. For Encke, we've seen 10 times. And there are other comets, I think Borelli, and a couple others that we've observed 8 times. And so we've been able to see a lot of them as they come back over the years. So how do we make sense of this? We have all of this data. How do we get any answers out of it? Some comets in our database have only one data set. while others have upwards of 100 data sets. For Halley, we have 816. For Hale-Bopp, we have 332. Most comets have more between like, excuse me, 5 to 50 data sets. Excuse me. So to properly compare one comet to another, what we do is we calculate mean values for the parameters that we're interested in comparing. Excuse me. And so things that we look at how active are their surfaces. So their general activity levels, we look at their chemical compositions, what are they made of? And our goal again is to determine which characteristics are due to evolution, which is how many times and how closely they've passed by the sun. So how processed is their nucleus? How hot has it gotten? How many times has it been baked? And then we want to tell which characteristics are due to their origin, which again, this is where they would have formed. So one thing that we look at is water activity. So we measure OH, a direct byproduct from water. So we can take our water production and we use a water vaporization model to calculate the area of the surface of the comet that must be active to produce the amount of water that we're seeing. So we can calculate the active surface area for the comet based on our production rates. And then we can take it a step further. If we have their nucleus size, we can say what fraction of the surface is active. And so we get an active fraction. And as an example here, I have, this is 67 PCG. Again, this is from the ESA Rosetta mission. Our water values say that it has a 2.5 kilometer active surface area. And we know from ESA that its effective diameter, you notice this is not a circle and I'm saying a diameter, right? So we take its various dimensions and in astronomy we call it pretending it's a spherical cow, right? So we look at that, we take the dimensions, pretend it's a sphere. And so we know, so it has about a 3.5 kilometer effective diameter. And what we can use these two values to say that approximately 7% of its surface was actively sublimating water while we were observing it. Oh no, looks like we're half loaded. Okay, well.
You want me to try to fix it?
I think I can get through this one without it. They're very similar pictures. It's a little bit different though. We'll keep going. So 196 of these 220 comets we have water measurements for. And so we've broken them down and we're looking at them by their dynamics. So the new ones are at the top and then the older Jupiter family are at the bottom. And so these new comets, they're coming in, they're seeing water for the first time. And so we can see that they have larger active areas. Makes sense, right? And so the dynamically new, the young long period, then as we start getting more evolved, these comets, as we go down, they've been around the sun more often. And so we can see that their active areas are getting smaller. And then the plot on the other side was showing our active fractions. It shows pretty much the same trend, except for two differences. One, you see these question marks at the top, and that is why don't we have no nucleus measurements for dynamically new comets? Does anyone have an idea as to why we have no idea the size of any of our dynamically new comets?
Because most of them have been around for a long time.
Well, they're so active. So these are the brand new ones. So these are the ones that haven't been around the sun before. And so these are the ones that are seeing the sun for like the first time, maybe the first time ever, or maybe they haven't seen it. Yeah, they're so overly active that we can't separate their nucleus signal from their coma. So by, you can kind of extrapolate that they probably have very huge active fractions, even though we can't measure them. It's pretty safe to say that a lot of their surface is active. And then as you go down to the comets that have been around more frequently, the active fractions keep getting smaller until we get to the Jupiter family, which actually spreads out again. And the reason the Jupiter family, these are the ones that are controlled by Jupiter, they're coming around every 30 years or less. The reason that they have this wide range of activities is that they're constantly being fed in from the Centaur region. So we keep getting new ones coming into the population. And so the majority of them do have smaller active fractions, but we kind of have a tail that goes out to larger active fractions. And these are ones that have probably been in the inner solar system for a shorter period of time. And so they're still burning off some of their volatiles. Oh, no, this is an important one.
I have an idea.
Okay.
Fix it, fix it. It's the browser, it's not your presentation. Download it, it's a PDF. Open the PDF.
Okay, thank you.
Still downloading.
Oh, there it is. Yay. All right, we're back to business.
Want to do full screen. Which I thought was F11. Oh, okay, I have to do. Oh,
Oh, but we'll keep going here. I think we can do, let's see. Oh, there's my spectrum, so that's where we, okay, my picture's back, yay. Okay, so this is where we were. And as I just explained, I just talked about this one, this is where we're seeing that spread of activity for the Jupiter family comets. So again, those are the ones that are being fed in. All right, so there's a lot going on with this plot, and so I want you to zero in on this one that's got the big star on it. We're now looking at chemical composition, so I'm kind of switching gears. We're looking at the evolution and surface and water activity, and now I'm saying looking to see like what other chemical signatures are we seeing these comets. And so for these, we look at production rate ratios relative to OH and CN. So we want to know how are certain species behaving relative to one another. And this is not using the entire database of 220 comets. We've actually narrowed this down to 135 of our well-determined comets. What makes it well-determined is that we observed it over at least 2 nights. We had at least 3 complete data sets, and our observations were obtained within 3 AU. So that's within 3 astronomical units of the sun. We use that cutoff because that's where water activity really ramps up, and outside of 3 astronomical units, water is not as active. And so we've narrowed it down to the comets that fit that, and a couple extra comets actually fit that criteria, but they had large uncertainties. The data looked good. This has been fully analyzed data. I've looked at these so much. And so we narrowed it down to ones that we felt really good about the numbers we were getting, and because we wanted to make sure that we weren't basing our compositional analysis based on a spurious measurement or an error or something weird that happened. And so what I want to point out in all of these plots is that the vast majority of comets are kind of this yellowish green. We call them typical because they're all kind of the same. That's 102 out of the 135 comets are typical in composition. So they're very similar to one another. And then we have these various other little groups that we have determined. And the main one that I'm talking about tonight is our carbon chain depleted group. It's these guys right here. They're kind of in a teal color and in a darker blue. And what carbon chain depletion means is that their C2 and their C3 signals are depleted. So they're low compared to the typical comets of the normal comets. And so we see this chemical signature sticking out in a lot of these plots. In this one, we see them down here in this plot. And on pretty much all of these plots, they're sticking out in some form or another. So that's great. We see different ranges of compositions. We see these different compositional classes. So how can we determine if it's because of surface evolution or if it's because of where they were formed? So about 15% of the comets are carbon chain depleted. Oh, I guess I should explain this plot first, shouldn't I? So this is C2 to CN ratios. And this on the x-axis, this is kind of a funny thing. We call this the Tisserand invariant with respect to Jupiter. But the main thing we need to know right now is that values between 2 and 3, this defines the Jupiter family comets. This is based on their orbital. This is based on their inclination, which direction they're going, and how they're controlled by Jupiter. And so this group over here is Jupiter family. And I think it's pretty obvious. Most of our carbon chain depleted comets are in the Jupiter family. 43% of Jupiter family comets are carbon chain depleted. And 85% of the carbon chain depleted comets have a likely origin in the Kuiper Belt. So that's a pretty large chunk of them. And that's cool. But again, is this because of surface evolution, or can we say that this is because of their chemical, like their internal composition? Is this because of where they formed? We weren't really able to answer that question until 2006. In 2006, we observed this comet right here where my little arrow is, and this was 73 Schwarzmann and Bachmann 3. So SW3, after it came around in 1995, it actually broke up into multiple components. And what that means is it had big outbursts, and then there was the main body, and then we had several smaller bodies following behind it in its orbit. And we have observations of it from 1995 before it broke up. We do not have OH, so it only shows up in this top left plot where we have CN. It's these teal kind of cyan colored squares. And these are its C2 to CN ratios. In 2006, we were able to observe 4 of its components and measure their chemical composition. And what you can see is they are all very similar to one another. So all these various components all have the same chemical composition. And it's also very similar to what it was before it broke up. And this is one of our very strongly carbon chain depleted comets. And so what we learned from this comet is that this very strongly carbon chain depleted comet was depleted all of the way through. So this implies that its composition was due to where its origin, where it was formed, and was not due to surface processing or surface evolution. Additional evidence that these chemical signatures that we see are due to where they formed versus processing by the sun is that most of our highly evolved comets, I was talking about active areas and active fractions earlier. So some of the ones that have been around the sun so many times that there's hardly any activity left on them. We call them anemic comets. There's just very little outgassing. They all have typical composition. So they're all in this big group of comets that are all the same. So this is further evidence that even with all this processing and all this exposure to the heat of the sun, they have this normal typical composition. Now I'm going to talk about Borisov, our interstellar comet. I've just been talking about how we have these very distinct compositions, and Borisov is this weirdo that came in, and it was started out as being incredibly depleted. First measurements, these are upper limits, so it was very faint. It was hard to get a lot of data on this comet. And so these are upper limits from various researchers. This is C3 to CN and C2 to CN. So again, these are our really depleted comets. And so our first data from it was like, wow, that's really depleted. And then about a month later, we're like, it's still depleted, but maybe not as depleted. And then we get up here in October and we're like, well, And then our data, well, this is what we have, this star. And then another measurement a few weeks later. And so it was actually changing its composition as it came in. None of the other comets that we have this data on, we have a lot of comets where we have them coming in and going out, and so we can see how they're behaving relative to their heliocentric distance from the sun. And none of them show that, but Borisov came in and just kept changing its composition the closer it got to the sun. And so the going hypothesis is that it had accumulated at crust while it was traveling through interstellar space, and we were just seeing that burn off. But we don't really know, and we're never going to see it again. So maybe we'll get some more interstellar comets coming through so we can test that out. So the big picture is that all evidence that we have suggests that the comets exhibiting carbon chain depletion have this composition owing to the conditions in the early solar nebula when they were formed, rather than to recent evolution after they arrived closer to the sun. We assume that the temperature where they formed was a key factor in this, and we think there was a gradient, as you saw in this compositional plots. We had those carbon chain depleted comets, but they weren't all in one clump. There was just this gradient of them. They were spread out. And so we assume there's a temperature gradient where these were formed. Also from the Rosetta mission, there's evidence that comet CG formed at very low temperatures. And so we think this implies that, again, and CG is one of our carbon chain depleted comets. And so there's a lot of evidence saying that they formed farther away from the sun. And that, again, this was due to their place of formation. And then just briefly what comes next. Next month in June, I'm going to the Asteroids, Comets, and Meteor meeting. It's a meeting that happens every 3 years. It's going to be in Flagstaff. We're hoping to talk to some of the dynamicists. The dynamicists are the people who make models of how the solar system formed. And so we're really wanting them to incorporate what we're seeing into their models, because we don't have anything that explains this yet. We have ideas of what's possibly happening, But it would be lovely if this could somehow be worked in mathematically and they could make models and we could actually see it work. So we're working on getting this published and hopefully this can be worked in. And then I can just leave this up for a minute, but I just want to mention that this is just one small part of our comet research at Lowell. We're working on a giant database paper. Been working on it for a very long time because we keep running out of money to work on it. But what I presented tonight is just a summary of just 2 sections of 5 result sections that we're going to have in this paper. We have published individual comet papers. This is the photometry for more than 20 individual comets out of this database. We're currently writing up our photometry results from Hale-Bopp. We just got a NASA grant that started about 1.5 years ago. That's allowing us to get that all written up and published. And we can also use photometry for some comets to determine the rotation period. Halley is one of them. We actually see production rates going up and down, and so we can correlate to its rotational period. We also do a narrowband imaging. We can use that to determine rotation periods. We can use them with 3D models to determine locations and dust and gas jets on a nucleus. And we published a lot of those results as well. So I hope I didn't go too long. And I put my email up here at the bottom. It's my last name there, BAIR@lowell.edu. And so I'm happy to take any questions now. But if you think of anything or want to talk to me about anything, please feel free to contact.
Another question that
Yeah.
is curiosity. Are you taking all your observatory from Lowe's or you are getting it all over?
The photometry is currently just from Lowell. In the early days, we had a Southern Hemisphere site. We actually used that through Hale-Bopp in Perth in Australia at Perth Observatory. So we do have a Southern site where they have a phone photometer of our photometer that they use at one of the telescopes down there. And then in the early days, we did a lot of the Halley stuff at CTIO because a lot of the time it was a Southern Hemisphere object. So CTIO is in Chile. And we do have maybe 5 nights from the early 80s that are from Mauna Kea in Hawaii. But the vast majority of this is all from Lowell Observatory from the same telescope.
Thank you.
I have 2 questions.
Yeah.
One was what you mean by a data set, because you said over 2 nights you had 3 data sets.
It's all very confusing.
Yeah.
Okay, so a data set in general is, thus we have. A data set consists of a set of measurements through the filters, and so one data set has to have at least 1 gas filter and 1 continuum filter. The majority of them, one data set consists of 5 gas filters and 3 continuum filters. And so that is a data set. And then for our compositional studies, we said, okay, we want to make sure that we're confident in our numbers before we use them for this sort of analysis. And so those have to have at least 3 complete data sets. So they need to have at least 3 sets using all 8 of those filters observed over 2 different nights. And so hopefully that answered. Okay.
The second was, is there any speculation as to what the crust composition was on Marisol?
That's a really good question. And we don't know. There are people who measure, one thing I love about the comet community is we're just narrowband. There are people who do IR and radio, and we all kind of work together because we know we can't get the complete picture without everyone else's data. And so there are some publications that were done for IR, infrared wavelengths. And I know that they detected some other species, but the consensus has been, this looks kind of like a regular comet, except it's changing and we don't know why. So, but the best idea I've heard is the crust, because I don't know what else it would be.
Ambiguous what the crust was.
Right, yeah, probably just something that little part of, I don't know.
Aliens.
Aliens. Yeah.
It could be alien.
It's very cold in space.
It is very. Yeah.
Yeah, of course, being the engineer, I'm thinking about how I assume this run for a night is all programmed and set up and happens automatically. You hope anyway.
It's programmed. We actually have to have a person at the telescope.
At the telescope, okay.
Yeah, these are person intensive observations.
That's what I was wondering.
Yeah.
How intensive. Have you been out there having to do it?
They're over.
I haven't in a long time
Okay.
because I'm a morning person.
That's a good, very good.
And then I had a child
Yeah, I understand.
and it made me even more of a morning person.
It's equipment from like, you said from the sixties and seventies,
Yeah.
right? So it's not fully, I'm sure they've upgraded certain
Yeah,
parts.
we've upgraded, but it's still, so when we do a measurement, so we center it on the comet, then we have to subtract sky. And so we have to center the comet in our aperture when we take the measurements, and then we have to move away to get the sky measurement. And then when we move to the sky measurement, we have to make sure there's not a star in there or something contaminating it. And sometimes we have a general distance we like to move away. So the sky just, it removes any like atmospheric contamination you might be getting. So we do the signal from the comet and then we do sky just to subtract out of it. And so we actually need a person there because there might be a big star in the aperture when we're getting the sky. There are all sorts of random things that can happen. And so these are all person hours at the telescope. Yeah.
When you're outgassing drops down to that really low level, do those comets then become a lot less bright magnitude?
They do. And what's really cool about a lot of those, since they're a lot, they're not as, they're lower magnitude, but we can detect their nucleus signal. So for a lot of those, we can get light curves from them and get their rotational periods. So the cool thing about that really low signal is if we can still detect them, then we get the brightening and dimming as they're rotating. And so we can get the rotational periods from them. But
They
yeah.
just eventually become big rocks.
They do, and there are actually a few comets that have the designation of D, which means dead. Yeah, so they're ones that periodic comets that were seen a couple of times, and then they haven't found them again, and after, I don't know the threshold, but after enough time goes by, they just call them dead and put a D.
Wow.
So between a dead comet and an asteroid comet.
Defined by the orbit, and so, but there's a really, it's all a gradient, right? And so the thing I love about this is the more we learn we don't know, and then the more questions we answer. Because the more we fill in the spaces and the more we fill the blanks, the more it becomes a continuum, and you have to decide where do you set those boundaries. That's not a question that I feel that I'm able to answer, and I think a lot of people have very strong opinions about how it should be answered. So yeah, it's a good question. Thank you.
Thank you, Allison.
I comment.
Yes, there's more up here if you would like. I'm not gonna toss them at you.
Freshly squeezed.
No, we say freshly sublimated.
Ah.
Sorry about the technical difficulties. This is a rather recent laptop for me, and I thought I had everything working, so. Glad we were able to do the PDF to get around that issue. If I can just get it out. Now we have the business meeting coming up. So we can take another break,
12 minutes.
a 12-minute break, 13-minute break for 9 o'clock. Okay, thank you. Oh, that's right.
The screen.
At 9 o'clock, the screens go up.
Start at 9:01 and get them back then.
Oh, Kim says, good luck, Bill, on 6 more carbon stars. She heard your conversation earlier. Louis says, thank you, great talk.
You have a chance to go to the luminary.
When people say, there's no. Yep.
We gotta get
Hello, welcome back to the business part of the meeting. Secretary's report. I'm gonna bring this to you.
Does anybody actually want to hear this?
I mean, we could just,
Well, it's in our, hang on.
put it on the screen.
It's in the Stella.
It's in the Stella.
Stella.
You could give us the highlights.
Just a second. Stella. Yeah, the font's going on. That shouldn't be read like that. There should be some more there. What'd you say, Bill?
We could make a motion just to accept them as presented in the Stella.
Yeah.
Okay,
So moved.
so there's Bill.
No, seconded.
Lee. All right.
Usually read them.
A motion has been made and seconded to accept the minutes as presented in the Stella. All those in favor say aye.
Aye.
All opposed? Thank you. I gotta make a note in the Stella. No. For my notes here. Okay.
Excellent job, Diana.
It was real quick.
Oops.
Great
I
work
just
as always.
Closed my browser. Hey, all right. Should have done that. Anyway, treasurer's report, income was $324.79 in dues. There was a $24.65 cash donation. $30 Astro Park building rent. For $379.44 total. Expenditures was $166 for the post office box annual rental fee. That's gone up $10 since last year.
Oh, God.
$75 Earth Day booth rental. $86.74 for 2 storage bags for display stands. Thank you, Nina. That's right, those are amazing. Total expenditures of $327.74. The account balance end of the month is $15,690.65. Before we do vice president, I got a call from Mike Gallagher the other night stating that if I wanted to get the check that I asked for to come to the park and meet him. And it's like, I didn't ask for a check. So somebody skimmed our website, pulled out names and the email addresses out of the Stella and sent a scam email using a fake Gmail account to our treasurer, saying it was me asking for a check. Now, I'm gonna submit the email. I gotta work with Mike on getting this submitted to get that account closed. If they've been doing any more, well, it's probably already closed. But I talked to him and said, I didn't make a request. Disregard that guy. Don't pay attention to them. So
Make a request like that.
I would not make a request like that.
Were you in jail?
No, yeah. He just said, I need to pay a vendor is what it said.
But the actual email was fake.
Yeah, but they put the name as
Your
John
name
Mars.
on there, but
Yeah.
that's why I said, well, who was Mimi? Yeah.
Yeah.
Cause in
This-
no way of tracking them. I said,
I've seen this at previous jobs where
Yeah.
they go to the website. They find who the accounting people are and they just start sending emails to the CEO. Hey, we need to get this approved real quick. Can
Yeah.
you approve this to get it done?
I've had the exact.
And then
same one.
it just happens. It's
It's a very common scam.
Yeah, it's not uncommon. It's more of education of when you look at the email address, this is not my email address.
Yeah, I always skim over and anytime.
Yeah.
Cause I've gotten them, but.
Plus, if you notice, I have a signature at the bottom of my email.
Mhm.
There was no signature in these emails.
Well, plus what are the odds you're asking for a wire transfer versus,
Well, yeah,
because they didn't ask for a check, they asked him to wire like
Oh.
money.
well, they did.
And then Mike wasn't gonna do that, so he,
He said, I can't wire that, but I can meet you at the park. I'm gonna be over here doing this event. You can come over and meet me. And there was a voicemail on Kelly's phone and I'm like, whoa. And I said, I gotta call him right away. I said, don't. So that was interesting to see that our little org has kind of garnered some of that.
the numbers game.
We
for
should
that.
put it in the
Was our account
newspaper for
compromised
free
in any way?
advertisement that we got caught and found out it wasn't real.
One of 1,500 people, they did that too, and if they get one person to send them the money, then
Yeah.
that's their pay for the day, for the week.
But what's really starting to scare you is AI being smart
Yeah.
enough to make a voice that
Pass
sounds like.
pass a Turing test,
Yeah.
Yeah.
at least
There was a
conversationally.
thing
Not
on the
fun.
news where the guy who pioneered AI is afraid that it's coming too fast. And it sounds like science fiction, but he's talking about it's going to take over the world. And he wasn't kidding.
It kind of depends.
Once it starts programming itself, right, with that singularity.
Vice President's report. Hi, Mr. Condrey.
Hello, as I reported earlier, excluding both myself and my wife and Mike Gallagher, we did have 8 other visitors to Astor Park since the work party. I checked the lighthouse and I noticed that there were no maintenance dates listed since August. So I want to get in touch with that company and find out what they've been doing that we've been paying them for.
Yeah, because it would have happened right before we did our maintenance, our work day. And I thought that it looked like it had been serviced.
Yeah, it looks like it's in good shape. I just want to know what's being done and when.
Yeah, me too.
And other than that, the site looked in pretty good shape. The surveyors came out. I noticed that the invoice for the surveyors is not listed in the budget. So I'm wondering if they've invoiced us for those services yet.
Well, it was something separate.
Okay. Oh, yes, I see. We've already encumbered those funds.
Yeah, it wasn't part of the budget. We decided to do it later and we voted on it.
Oh, yeah, that's correct. You're right. So the survey's done, and we just had to figure out what we're going to do with that from there. I believe our next activity is to start restoring some of the fence.
Yep.
So we'll have to set up a date to do that.
At the board meeting that we had in the April, we went through and worked on a spreadsheet that Mike had kind of provided us to fill in some items that would allow us to get amounts for the fence.
Okay.
Do we have that, like, I haven't seen the report, or if I can get a copy of
The survey.
the survey, or if you can look at it and figure out the linear feet of those 2 sides that we want to fence, and then you put that linear feet.
Are they gonna mail us a copy? Is that what's gonna happen?
Yeah, I believe so. We're going to mail it after they've filed it with the county. So we will definitely be getting a copy of this.
Okay.
So other than that, I don't have anything else to report.
We're probably gonna have to get a hold of whoever owns that field and talk to them.
Right.
I think we might have to call our friend who's at the end of the driveway and see if he knows who it is.
He knows who it is.
He does?
Yeah,
Oh,
he knows
Okay.
the farmer that's been farming it at
It's
least.
Terry, isn't it?
Yeah.
I got his phone number in a file.
I had it. I don't know what happened to it.
Okay.
If
Yeah,
you cheat, if you go down there, just go up and talk to him. He loves it when we come talk.
Sure. And the dogs aren't trying to bite my leg off.
That's why I go to the fence and he comes over.
Oh, okay, all right. What do you do, like this? Like, hey, come here. Okay.
Yeah, I'm going to be out of town next week, but when I get back, if we haven't gotten the survey report, I will reach out to the surveyor and see what's going on with that.
Okay, that sounds good.
You go also the warehouse guy, but the other guy was tearing it up.
Sorry. Sidebars, we apologize.
That's okay. Old business, as we just covered, the land survey report. Nothing yet on Prairie Stem.
I haven't, it's been at least a month since I reached out to Alan.
I was hoping to run into him at Steam Night
Yeah, so was I.
and they weren't there, so. Folks, in the Misrule Committee. The next meeting is the 3rd Saturday at the Ain Brand Exchange at 10 a.m.
Big OAS day, I guess.
It is a big OAS day. That's why I added a virtual option. Yes, ma'am.
I'll do virtual option.
You'll do virtual?
I'm not in town.
You're hosting? But yes, the OAS is hosting the Mid-States region of the Astronomical League's conference in June of 2024. Yes,
To go back to Astro Park.
yeah,
I talked to my boss about that steel roofing for the
Uh-huh.
shed, and he will donate
oh,
the steel roofing for that.
do we need to get him a letter?
I told him we could get him a donation thing. He was very excited.
Okay, great. I don't know if you heard that, Steve.
Yes, I heard that.
Great, awesome.
I have not worked up the estimate for the rest of it. Apologize.
No, that's fine.
We don't know.
No new business? I don't think we do.
We already talked about cooking at the park.
We haven't what?
Cooking at the party.
We already talked about cooking at the,
Okay.
at the Star Party.
Oh, I guess, I mean, I could, I am applying for that grant this month.
Oh, that's right.
Not really a business item, but
It is kind of a business. That's a new business item.
I do need to get those documents, sooner than later, like much sooner.
Okay,
probably later.
Mike is going to be leaving town on the 9th for the rest of the month. So I'm getting the post office box key. This might be something where we have to say, can we come over in the evening and work through it real quick? Rather than try to go back and forth on
Yeah,
it.
it was just like those
You know.
two financial.
Yeah. If you're curious what that discussion is, we're working on getting a grant.
The HDR Foundation has an employee grant program. My wife works there, so we're gonna apply for, I'm not sure yet, but up to $30,000 to get money to purchase telescopes for the library telescope program and a couple other things as well, maybe to help do outreach from like looted skies of library parking lots.
Very cool.
If you've ever written a grant before, it is a interesting process. And if you've ever written a grant before, let me know, because I never have and I could use some help. It seems like a pretty easy application. And Carmen thinks we're a shoo-in.
Okay.
Just from her internal, whatever, insider trading knowledge.
Insider trading. Don't say that.
Well, if you look at some of the other stuff they funded, we're at least as qualified as some of the random things that they've done in the past, so.
You know, we can discuss what we talked about at the board meeting about Astro Park. So we've kind of put together a rough 3-year plan to do incremental upgrades to the site. This year, we want to do the fence, the land survey, seal up that building. And then possibly work on the road and maybe a pad in the fall next year. And work towards that as well.
Big pad.
Big pad, 24 square for big telescopes. Or groups of telescopes. Maybe even possibly getting the piers fixed. That are out there.
Or adding.
Putting a universal plate from Dan's plates, or I think is what his name is. Interchange them out. Oop, I didn't see the chat question, sorry. Why not make friends with the dog and give him a big cookie? Oh, the thing is, there's about 3 or 4 dogs. They always stop right at the fence. They don't
Like
go over the fence.
15 feet from it.
Yeah,
And then they.
because we've had some people get startled when they're going down there. There was a downed tree at Astro Park. In the road, Mike Gallagher has cleared that. It was cleared like the left side lane of the road. So that got cleared out. Yes, Tom?
Is it down just where you took, you got the road goes to the dog leg of our property?
I think it was on the.
No, it was
Further going in.
Up on the,
It's up.
It's alongside the road, so if you want some wood.
No, because
Up
when I
closer
cut
to
the
the
last one
Vesuvius
down,
border.
there was a spider about that big on the damn thing. So yeah, remember there's spiders down there.
Well, as long as they eats the
More
ticks.
spiders.
They never do that. You know better than that. They don't even like mosquitoes
And
or possums.
maybe even possibly some prairie grass on that hill. Just try to prevent some more trees from moving in.
Yeah,
We took down a lot of bushes, a
a
lot
lot of
of
scrubby
bushes.
stuff.
You would almost not recognize that part. It's so clear.
Is your parking lot in your 3-year plan?
I hope so. Let me make a note.
Throwing it out there, part of the road rocking, right?
Yeah, that's like.
Well, the parking lot used to go a lot more further to the northeast of where it is now.
Yeah.
We put those poles in hoping that the mowing would happen.
Right.
We may need to talk to our mower, Steve, about mowing to the poles that we added.
Also, the divot, just as you go down to the driveway, that empty spot. Where you gotta make a turnaround, we were gonna put what was left of that building in there. That they took down.
Well, we were thinking about reusing those cinder blocks as erosion control where the culvert is.
Hmm.
So we'll need a couple of sledgehammers.
What size?
Well.
5-pound little ones or,
Mhm.
okay, that's not a little one.
Probably both,
You're just gonna break them up.
yeah.
You just get somebody that got an ankle problem, say, here you go, have fun.
As long as they don't throw their back out.
Anybody got a 13, 14-year-old son, it'll be perfect for them.
I got a 16
Got a volunteer right there.
can handle it.
What's that, Steve?
I got a 16-year-old who could be put to work. I think he can handle it.
There you go, see? He'll sleep good that night.
It's a good question on the.
Is there any news from Discord affecting us since the recent incident? No, we should not be affected by that. Since anybody can set up their own Discord server. It was sort of all their little buddies doing their own gaming thing. I don't think that's gonna affect us in that case. If you're not aware of that, the individual who was leaking secure documents on Discord was a National Guard member, so. A lot of people use Discord, it's just a tool like any other tool. What?
The scammers.
What? Arla, we can ask guys going through divorces to come work on the down tree. So. What was that?
Sneeze.
Oh. You ask and you shall receive.
Yeah.
Gosh, I feel like I kind of have a feeling I'm missing something. I don't know what it is. Oh. In regards to Nisroll. I'm probably gonna buy the domain for next year. Cause I need to put some flyers together so that they get taken to Nisroll this year. So that we can put them on a table somewhere to say. Here it is next year, watch this space.
That's like $30.
Don't they just use the same server all the time? The same,
Well, Tulsa is using Wix for their site.
okay.
Don't worry, Mike. Cause they've got miserable 2023 .org. So I figured we'll get 2024 .org.
So what I did, John, is I think I made up like little save the date reminder cards to hand out. Before, the year before my conference I hosted.
So, yeah, I've got a whole bunch of postcard sized cards at home that could be printed on. I think I bought like 100 of them.
Print the OS logo and say, save the date, Omaha, Nebraska.
Yep.
I move that John buys it with domain.
Oh, a motion.
That required, or do you have discretionary spending and just take care of it? Or does that just come out of the miserable funds that we have?
Well, we haven't even set up those fund budget yet.
$750 in seed money,
If we decide to get the seed money,
it's an optional thing?
I don't think
It's
we're,
optional.
we don't have to get it.
It's optional.
Why wouldn't you get it? Just because we have enough money and can handle it on our own?
It'd be easier to not.
Because, well, you gotta pay that 750 back in addition to any money you make or lose.
What, how much is
Oh, if
this?
it's a loan, then yeah, we're probably fine.
Yeah,
That's
well,
basically what it is.
when we did it, we made what, $3.
$3. Or
Even.
so many cents.
Something like that.
How much? is this?
No, actually, what-
750.
the convention is supposed to be a moneymaker for Misrule. That's what keeps Misrule liquid.
For all those expenses. All those good services they provide.
That's why we sell t-shirts. to
Oh,
fund
yeah,
it.
and it comes out of Tulsa.
That's reported.
If we want to sell t-shirts, we can sell t-shirts and that can be part of the funding for the optional extra. What are you thinking, John? I know this is a miserable thing, but it is kind of like we're really club doing it.
I'd say we probably don't need to.
It's in tight.
We probably don't need the seed money. I mean,
I don't think so.
I mean. Mike's like the treasurer anyway, right?
He's the treasurer for both,
Yeah.
yes.
But okay, we got
There
a
you go.
motion on the floor. Motion on the floor that is
Hold on,
needed.
no.
If it's needed, then we need a second vote that to go ahead and buy a domain name for Misrule 2024. Is that?
We don't have a second.
Second it.
It's Tom Wilson,
And you're
second.
saying it's a nominal $30?
It's high end $30.
Really?
Probably any 15 to 20.
I'll donate the 30.
Just,
Oh,
yeah,
all right.
do it.
Not your discretionary spending.
Or
You don't even see.
it's a
Or not.
donation. One of those things.
$30.
No. Unless we get like .net and .org and .com and
Then
Yeah,
it gets-
yeah, we want all
.xyz.
.biz.
A motion has been made and seconded to purchase a domain for Misrule 2024. All those in favor say aye. Opposed? Thank you. I'll get on that. I'll work with our webmaster to put that on the same account for us. And the nice thing is that with Hover's domain, I can say forward it to any other site, or I can even throw it on my web server. And put it under WordPress. Oh, I could make it. So you mentioned the grant info, that's the new business.
Yeah, that has to be
Main,
June 1st at 5 PM is the cutoff.
June 1st.
Yeah, I have to have the application in by June 1st at 5 PM.
End of business day. Okay.
How much stuff? Currently up for about 18.
Before the meeting started tonight,
18,000.
I gotta make sure I get this right, hang on.
Something that would be good. And
The Omaha Astronomical Society was the recipient of a donated telescope by Jay and Laura, they were here earlier. So It's in my car. Is an AVX and a 6-inch Orion RC. Astrograph. About that big. It is custom wooden cases to carry each. With a tripod bag. For now, I'll just store it at my house. It needs some work on it anyway. But I said that to put it in the minutes, so it gets recognized.
6-inch Orion astrograph, AVX mount, tripod bag,
Mhm.
and you said it
Cases for the head and the. Cases for the mount and the telescope. Collimator. Cords to connect to a computer, et cetera, et cetera. We'll look at it when we're done.
you said it was J and tomorrow.
Yeah. They were sitting at the table earlier before the business meeting. Laura and Jay Gibbs. GIBBS.
Well. Whenever you get a day, a breather, if you want. I'll give me a heads up.
I think I'm gonna go over Sunday.
That's Sunday, this
I
Sunday.
don't know.
Any other items? We could have social time if we finish this meeting.
Motion to close.
Move to close.
Fun.
Yeah.
Tom Wilson. Gesundheit. A motion is made in second to adjourn this business meeting. All those in favor say aye.
Aye.
Is that hand up back there?
Who said opposed?
I just getting you. Don't worry about it. Okay, thank you. Hooray.
Hey, good stuff.
Recording stopped. Here we go.
Always trust Bill to put it into